Hello, this is Nelson Brown. These are the extra time slides that were done about process flow and integration testing and continuous integration methods employed for the CS 631 project for Dr. Oria at NJIT in the spring of 2018 term. So I thought that it was important to talk about process and flow because a lot of times what I notice as far as students coming out of certain programs is that they need to get educated on some of the tools that are used, and there is no one specific course or subject where these tools are specifically taught. Or if they are, then it becomes a little bit more onesie twosie, especially in a computer science curriculum where really the focus should be on theory and implementation of that theory. However, learning some of these practical tools can really help out some students in their careers. This was one of the first courses and really one of the first professional level projects that I had been through where I hadn't actually verbally ever talked to Jean-Paul. And I don't think that is a negative in the slightest. And in fact, I think I engaged in more communication with him through this process than I had in many other projects that I've been on, where issue trackers were employed, but verbal communication and set meeting schedules were constructed and adhered to. So without further ado, I'll actually talk about the process. So we used an issue tracker along with testing and continuous integration using the Bitbucket platform and a concept of pipelines. So Jean-Paul and I each kept a separate branch. I was on the users Nelson branch and he was on the users Jean-Paul branch. And we would push to those branches after branching off of the master. So the reason that we would do that is to keep each other abreast of what was going on in each other's branches. So if I'm agreeing to work on issues 4, 2, and 5, and Jean-Paul is going to work on other issues, then I see as he works on them what they are without necessarily having to merge those change sets together all the time and stepping on each other's toes. In select instances, I may choose after I see or I communicate with him that a change set is fairly mature, but there's some need for integration between us. I may merge some of his changes at an appropriate time, but more often than not, change sets are merged through pull requests. So after I get to a state where I feel I have a number of tests written that are fairly adequate and robust, and after I feel that I've completed a set of issues that have been assigned to me, then I create a pull request off of my branch back into master. Now I could do this manually where I git merge the master branch with my branch and then I push that change up to GitHub. But that doesn't give the other team members adequate time to actually review the changes that you had made. This creates a actual time to collaborate between your fellow developers and yourself. What actually had changed during your development cycle. And it also gives it a concrete definition in the sand. I created pull request number 14, and I can choose to accept that pull request and merge it in, or I can decline it and provide the reasons why I think that it should be declined. I can also comment line by line within this tool what I think is right or wrong. And this is completely free. So that's a little mind-blowing, is that some of these collaboration tools, I can create a private repository, I can do so behind closed doors, and then I can turn it all around and open to the rest of the world at the end of my project. And I can collaborate and do so without ever actually speaking with another member of your team. Yet having full communication and broadly defined scope. So one thing that we did do was define tests. So tests are integral to this process. Not only do they confirm, some people like to use test-driven development where they define a test first before they even attempt an implementation. I'm not going to talk philosophy with respect to that, but tests can be very important from the perspective that they confirm that your code works in the way that you think that it does. And other developers can look to your tests to say, hey, how does he think that it works, and how do I think that it should work? And it can be used as a collaboration tool as well. So there are many different tests. For ours, we fell under use cases. So for the administrative user, they can register new members, they can register a new instructor, they can create exercise types, etc. And each one of these tests can employ two types of ways. They can do direct service calls, so they can pretend as if the test itself is the controller that are interacting with the service layer, fetching out what the individual rooms and data entities are, and then invoking the service layer logic. The other way that you can do it is actually pretend to be a web browser within these tests and submit a post request to admin exercises create with the parameter data that is associated with creating a new exercise, what its name is and what its description is. I do that as a particular user, the get administrative user, and what I should expect at the end of that is that the status is returned as a redirection back to the administrative panel. And then I can do service call requests to make sure that the controller actually handled my response appropriately, that I can find one exercise with the name that I did not see that existed prior. So I know that the controller is actually interacting with the database to actually do the things that I am requesting. And we had some other stuff that isn't related to that. Some other further explanation about what the config is. I'm going to skip over this. So I'm going to actually end this at that point. I just kind of thought that this was, a really enjoyable experience from my perspective, collaborating with someone in an educational and academic setting, using tools and really treating this in a professional way. So thank you for your time. I really enjoyed working on this project, and I'll end the video there. Thanks.